Have you ever stopped to think about just how complex, I mean, really mind-bogglingly complex your favorite computer game is?
Oh, absolutely. Millions of lines of code, yeah.
Exactly, and all these intricate systems, player interactions, branching out. It's wild. But the real tricky part for designers, it isn't just the coding.
No, it's communicating the feel, the flow of the gameplay, getting everyone on the same page.
That's a huge challenge. There isn't like one standard way to do it, is there? Especially for modeling player choices and outcomes dynamically.
It really relies a lot on intuition, trial and error. Lots of iteration.
Which brings us to our deep dive today. We're looking at a really interesting idea using classic game theory to formalize and maybe simplify game design.
Yeah, it's fascinating stuff, taking these established concepts.
Like adapted decision trees and payoff matrices.
Right, and using them to build compelling, balanced gameplay. It's a neat bridge.
Let's jump in.
So yeah, game theory, most people probably know it from economics, right?
Mm-hmm.
Studying decisions.
Strategic decisions, yeah.
But applying it here, it gives us a formal way to look at what actually happens when someone plays the game.
Okay, so it's more than just did the player win or lose.
Way more. The paper talks about utility.
Utility, meaning?
Basically, player satisfaction as a way to measure kind of how good the experience feels, not just the score.
Ah, okay. And you mentioned something called the saddle point property. Sounds technical.
It is a bit, but for game design, it points to those dominant strategies, the easy wins.
Like that one overpowered weapon or tactic.
Exactly. The kind of thing that makes the game less interesting because there's one best way to play. Game theory helps spot those.
Gotcha. And the payoff matrix, I've heard of that. Like a grid?
Yep, a grid mapping player decisions against opponent decisions, showing the outcomes. Standard stuff in strategy.
But applying that to a whole game, or even using a formal decision tree, doesn't that get impossibly huge?
Oh, completely. You take even a simple game like tic-tac-toe, the number of possible moves just explodes.
Right. Forget about a modern computer game.
So you can't map the whole thing. The innovation here is using adapted decision trees.
Adapted how?
They focus just on smaller segments, like one mission or a specific interaction sequence.
Ah, okay, that sounds more manageable. Practical.
Totally. It becomes a useful framework for designing the flow on that smaller scale. They even have a visual shorthand.
Visuals? Like what?
Simple shapes, like boxes for fixed things, say a wall or a turret, ovals for things that move, like enemies or NPCs,
Okay.
and diamonds for items you can pick up, like health packs or keys. It makes the design easier to read at a glance.
Nice. And the branches of these trees?
Those represent game states, like how much ammo you have, your health, and also player inputs.
Inputs like speed, accuracy.
Exactly. How fast you're moving, how well you aimed that shot.
Yeah.
It maps the choices and consequences within that segment.
Which links back to that utility idea of player satisfaction, making sure there are meaningful choices.
Precisely. And it helps you deliberately design against those saddle points we mentioned.
Right, avoiding the cheap wins, the shortcuts that kill the fun.
Yeah. By seeing all the potential paths laid out, designers can ensure there's variety, that different approaches are viable.
Okay, so the adapted trees help structure specific game segments and avoid those fun-killing shortcuts. But what about the overall difficulty? Balancing the whole experience.
Right. That's where the payoff matrices really shine for designers.
How so?
They help model player decision-making specifically to analyze skill levels and the challenge curve.
Can you give an example?
Sure. Think of Pong, like the paper mentions. One axis could be the player's aiming accuracy. The other might be the AI opponent's paddle speed.
Okay.
The cells in the matrix then show the outcome, maybe the angle the ball comes back at.
Ah, I see. So you can tweak the AI based on player skill, potentially.
Or just balance player versus player, or player versus the game itself. Like, how steep is the learning curve? Are the rewards right? Are different game features balanced against each other?
And this isn't just guesswork, plugging in numbers.
Well, designers might estimate things initially, but the crucial part is playtesting.
Real players.
Real players, yeah. Gathering actual data on how people play, what choices they make. That statistical data refines the matrices, makes them truly representative.
So you can actually start predicting player behavior.
To an extent, yes. Especially if a dominant strategy emerges one option that's clearly better than others in the matrix.
And that relates to Nash equilibrium. I've heard that term.
Right. Nash equilibrium is basically a stable state where neither player can improve their outcome just by changing their own strategy, assuming the other player stays the same.
So it represents, like, The optimal play for an average player in that situation.
Kind of, yeah. For designers, finding that equilibrium helps understand if there's maybe only one good way to play, which they might want to change to allow for more styles. Multiple viable strategies are usually better.
So pulling this all together,
Mhm.
what this means for you, the listener, is that game theory isn't just academic, it's a practical tool set.
A formal way to understand player choices, player outcomes, and to actually design better games. It bridges that gap between the high-level idea, the storyboard, and the actual code,
Moving beyond just gut feelings in design.
towards a more rigorous, analytical way to craft those experiences, make them compelling, make them fair.
And thinking ahead, this kind of structured approach, using game theory, it could lead to some really interesting places, couldn't it?
Definitely.
Imagine games that really learn how you play, assess your skill, and dynamically adjust the challenge just for you. Real-time personalization.
That's the potential, yeah. More adaptive, maybe even more engaging gameplay down the line.
A future I'd definitely be excited to play.